Our next speaker is Dr. Aron Culotta, professor of computer science in the School of Science and Engineering. That is Uptown, for those of you who don't know. Director for the Center for Community Engaged AI, which Patrick was talking about earlier. Dr. Culotta is associate professor of computer science. His research investigates computational methods to learn about human behavior from online social networks, combining machine learning, natural language processing, and social network analysis. His interdisciplinary research is supported by several NSF-funded collaborations with researchers in public health, political science, marketing, and emergency management. He's going to present on some of his NLP work today. Welcome.
Shooting for 10, right? 10 minutes? All right. Good morning. How are y'all doing today? Wow, Eliza, Simone. After my own heart, every NLP class I start with Eliza. I also wanted to start with a history lesson, but I'm not going back that far. So my PhD was in natural language processing in 2008. And in 2006 is when Twitter first launched. I'm curious, was anybody here born after 2006? I just realized that might be a possibility, but okay, no, so cool. So, you know, as an NLP researcher, we were studying news articles and things like that. And when Twitter came out, it was kind of revolutionary, right? Because suddenly one could access large volumes of stream of conscious data from the world, right? And this is much more exciting than parsing Wall Street Journal articles all day. So one of the first things we thought to do was, well, let's look at Twitter data to see if we can extract signals around public health quantities, right? And so the first thing we did was try to correlate people's conversations on Twitter with flu rates as measured by the CDC. I don't know if they still do that or not, but that was something they used to do. With actually very little NLP work required, we found like really strong correlations between kind of the volume of Twitter that's mentioning having flu-like symptoms and the CDC's reported rate. Okay, so this was a very long time ago. Of course, this didn't always work. And you know, for some time periods, we would do this and our prediction would be wildly off, right? And again, as a history lesson, the reason it could be wildly off is for, of course, false matches, right? And so that was actually a real example of our system going haywire, right? And so NLP matters, right? Our ability to parse the semantics of what these sentences are saying is really important to any kind of work in this space, whether it's, you know, flu tracking or, you know, chatbots or any other kind of language-based interaction with humans. So fast forward to 2023, so COVID years. There were other research groups that kind of did similar sorts of things to track COVID online and that sort of stuff. But as an indication of how things have changed over time, we decided to focus instead on vaccine hesitancy. And, you know, if you look online during COVID, of course, there's very rich discussions around vaccines and their efficacy or not. And so we thought, well, let's just see if we can parse these kind of utterances to tell a few things. Like one, can I tell that somebody got a vaccine, right? So this is somebody saying that they did get their vaccine, for example. Can I find people who were declaring that they will not get a vaccine, right? Maybe expressing skepticism over the vaccines. And of course, there's many examples like this, right? So just like in the flu case, we had to build language processing modules that could parse these types of utterances and categorize them in different ways. Like this is somebody who got a vaccine. This is somebody who is expressing negative or positive sentiments towards vaccines, right? And our goal with this, well, first of all, we wanted to align it with the actual administered vaccines, which were reported, right? So we know kind of how many vaccines were reported over time. And so this plot's just showing the administered vaccines, both on a 7-day and 1-day rolling average, along with tweets that our system said were somebody expressing having been vaccinated, okay? So it was pretty decent alignment. You know, it's a little bit of a lag, as you might expect. And then we threw on all the other measures, which was like quantity that expressing negative or positive sentiment, or maybe just neutral, no sentiment at all. And that doesn't have that pretty like 0.9 correlation that we've seen in other examples, which shouldn't be too surprising. I mean, there's a lot of conversation around vaccines, and they won't all, of course, align with the vaccination rate. But we thought, well, could we look at the attitude of a state or region around vaccines in, say, February, and anticipate what the vaccination rate will be in that place in, say, April, right? And so one way we tried to look at that was just to group for each state. We kind of computed two things. One, the fraction of positive vaccination tweets from that state in February 21. So this was right after the vaccines came out. And align that with the vaccination rate per state up to and including April of that year. So like forward looking, right? And we see, pretty strong correlations between those two numbers. And of course, there's a lot of reasons for that. There we are in the bottom left, Louisiana, hanging out with Mississippi, as we usually are. And also some weird outliers, right? Like New Hampshire way up there, like not as many positive tweets, but much higher vaccination rates than the model would have expected, right? And we can talk about possible reasons for that. So the next thing we did was build a forecasting model. So a time series model, we used LSTMs and particular type of neural network, where we observed kind of the Twitter and other signals up through time t and tried to forecast what the vaccination rates would be in time t plus g, whatever. And so this graph is showing kind of the main results. Here we're only forecasting 2 weeks ahead. We have other results farther. The blue is the truth. The red is the prediction of the forecasted rates of vaccination in different places. As a side note, we kind of repeated the same methodology, but for a totally different task, which was forecasting hurricane evacuations. And so much like vaccines, like, okay, there's this impending thing, a rollout of a vaccine, right? And then emerging conversation happens about that impending thing. There's an impending hurricane and conversations emerge. Am I going to evacuate? Am I not going to evacuate? Should I, should not, right? So we did a similar sort of thing to parse the messages in the lead up to different hurricanes to try to forecast evacuation behavior. And there, well, how do you know ground truth? Well, you don't really, but we do, in certain scenarios, have traffic data. So we can see kind of how traffic rates spike at different places as a hurricane approaches. We also have things like surveys. People do surveys kind of after the fact, which we can argue if that's accurate or not. But people will say, like, yes, I left at 2 p.m. on Tuesday, right? And so you get another measure of accuracy there. So we did a similar sort of thing. It's harder than predicting vaccine uptake, but there is signal there. And what's also cool is you can look in at, with this NLP, of course, you can find clusters of things and you start to extract reasons that people decided to either evacuate or not, right? And as a emergency response person, you might be able to look for like pieces of false information that are maybe leading people to wrong decisions. For example, one thing we found was that a lot of people decided not to evacuate because they had pets, because they didn't think that the shelters allowed pets, which they used to not do, but now they do, right? And so as a communication person, you might want to know, you might be able to want to identify these misconceptions to work on communication. Okay, so future opportunities. So I haven't really talked a lot about generative AI yet. I would say there's a couple obvious places that modern language models can be used. The first is most obvious is all of this stuff where we're trying to assign the semantics of an utterance. Of course, LLMs are great at, not perfect at, but pretty good at. And that our ability to do that has gotten so much better. There's a lot of issues with how do you scale that? How do you deal with the nuances of sarcasm in online conversations? But that is certainly one thing. The other area that we do a lot of work in is trying to perform causal inference from observational data when text is involved, right? And there's a lot of interesting work around that area using neural networks, where essentially you're using a neural network to kind of predict the counterfactual that you can't observe if you're into that language. One crazy idea I have that is in the lab now, we'll see if it works or not. So think about the following thing you might want to study. So say there's somebody who is kind of, looks like they're anti-vaccine. and you're a good public health researcher and you say, I'm going to do an intervention and I'm going to put out this message and see what effect it has on the world, right? To try to educate the world about the quality of vaccines. But you don't do an RCT. You just kind of put it out there. And so the question is, how do you evaluate that intervention just from observational data, right? And so you might see, for example, that, oh, look, this person used to say negative things about vaccines, and now they're saying positive things about vaccines, right? And of course, what you can't observe is what would have happened had you not conducted your public health intervention. All right, so here's the crazy idea. What are LLMs good at? Talking like humans. So could we train an LLM to talk like this particular user, train it on all their history, and then have it generate what we think they would say in the next 3 months? And so then the counterfactual, the thing before that intervention, is basically what the LLM says you would have said had we not done this intervention. So now we have the counterfactual, and we can use that to compare the observed as a way to estimate the impact. So I'm not sure if it's going to work or not, but I think it's one interesting way to use generative AI in these kind of scenarios, more for the analytics side and less for the human interaction side. But okay, happy to talk more about all these things later. Thank you.